Hi everyone, my name is Devapriya Sengupta from George Mason University, and today I'm going to show you how to do stratified covariate balancing using SAS. Let's open the SAS editor window for SAS 9.4, and I'm going to open my program that I already have written, and I will go through it to explain what I did to do stratified covariate balancing using SAS. So first I defined my library with a libname statement, and you can see in the log it says that physical name, this location was successfully assigned as my library. I already imported the data citalopram from the website openonlinecourses.com as a SAS dataset, but I'm going to show you how you can use SAS wizard to import dataset as a SAS dataset. You go to the file and then click import data. I saved my dataset as a CSV file because it is easier that way. I'm going to select comma separated values, click next, and then I'm going to browse where my CSV file is, courses, and you can see that's my CSV file. I will click next, and it will ask you where you want to store your imported data. I'm going to store my imported data in the work library and name it as test dataset, and I'm going to do a finish. You can see in the log work test dataset was successfully created, and it has 1933 observation. Let's go to my Explorer and go to the work library. You can see my dataset, test dataset, was successfully created. So that's how you import your dataset in SAS. Then I ran our contents. Contents is a procedure that you can run which will give you the contents of your dataset. So when you run it, you can see that all the variables that are in your dataset are listed according to the position of the variable in your dataset. So de-identified patient ID is your first variable, gender is your second, race is your third variable, so on and so forth. Next, we are going to do some data preparation, and I have written in comment section, the green part is a comment section, the steps that I have taken to prepare the data to do a stratified covariate balancing using SAS. I have written that diagnosis of panic disorder is our treatment. It is very important that before doing anything with stratified covariate balancing, we identify our treatment group, which is the panic disorder here, and our outcome is citalopram success, which is the outcome variable. I have renamed many variables, almost all covariates, as another to give them a shorter name for easy manipulation of the variables. I have 11 covariates that we want to balance, and we recoded these variables. We created new variables for each of the nominal variables. That is, if in your data set you have a variable that has 1 0 value or yes no value, we call them a nominal variable, and we create another variable such that if the original variable has a value of 1, then we will give the new variable a value of a letter, a alphanumeric letter. If the original value of the variable was 0, then we will set the new variable value as missing. For convenience, I have renamed the new variable. I have named the new variable with the underscore attached to the old variable. So if the old variable name was race, then my new variable name is race underscore. Now let's go to our data step. My original data set was in mylib/citalopram, and I'm going to create a new data set which is called citalopram, and I'm keeping the variable that I need. This will limit the number of variables that we are keeping in our data set. You can see in our race variable there were more than one value. It was not a 1 0 yes no variable. The race was white and black and Hispanic and others. So I have recorded such that if the race was white, then race underscore, my new variable, will be having a value of W, and if the race was not white, anything other than white, then race underscore will take a value of N. Similarly, if family history of depression was 1, then depression underscore, my new variable, will have a value of E. And if the depression, family history of depression was 0, then the depression underscore will have a missing value. This way I have recorded all the variables, all the covariates, and then I renamed my original variables to a shorter named variable. So for panic disorder, I renamed it as treatment variable, SIT success as outcome variable, and the other variables you can see I have shortened the name. Alcohol underscore abuse underscore diagnosis becomes alcohol. Then I create the strata by concatenating this cat s actually does the concatenation and takes out any spaces in between, concatenating all the variables that I have created, and that creates the strata. Let's run this one and see what happens. So when you run this one, you can see that there were 1933 observations in my original data set. My created data set, citalopram, which is a temporary data set, also has 1933 observation, but it has more variable than it originally had. So this is my temporary data set. These are the original values, original variables that I had. You can see the underscore, all the underscore variables are the new variables that I created. And these variables has one letter. And my strata, for example, FWE, this strata means this particular patient was a female, was white, and had a history of depression. Each strata represents a combination of the covariates that that patient had. Now, this part of what I have done here, you can also do it in Excel. So I'm going to show you quickly how you can do it in Excel. First, I'm going to open my data set, citalopram. this is my original data set, and I'm going to save it as citalopram data prep 2. So I do not want to change the original data set. You can see this de-identified patient ID. This is where I am shortening the names, right? So gender, it already has one letter, so I'm not going to change this one. First, let's get rid of the variables that we are not going to use in this analysis. These are the variables that we are not going to use, so I'm going to delete this. This is also something I'm not going to use. This one is panic diagnosis. This is our treatment, right? And then all of these are covariates that we are going to deal in a bit. I'm not going to use this one, delete, and the rest I do not need, so I'm going to delete these two. Save. Now where is my seed success? This is my outcome variable. Okay, now let's create another. This is family history of depression. This is depression, anxiety. I'm shortening the name, just what I did in SAS. Phobia, I named it OCD. Alcohol, drug, hypochondriasis. At this point I'm not doing anything special. I'm just taking out the long names and making shorter. Bulimia. Okay, and we are done. Now what I did in SAS was I created new variables for all the nominal variables. For example, race, you can see that race has white, black, multiracial, Native American, many values. So I'm going to create another variable, which is, I'm going to name race underscore. I'm going to write a formula if this column equals to white, then assign W, else assign missing. Okay, so you can see that if this is white, so I assign W, and I'm going to copy this formula everywhere. So you can see that if it is white, then it is assigning W. If it is black, then it is missing. So anything other than white, it is missing, right? So in the same way, I'm going to create another variable. It's depression underscore, where I'm going to copy this formula. Okay, paste. Now for this one I'm going to use E2, right? And this one is not white, actually this is one. Then I'm going to use, this is E. So what I'm saying is, if depression, this column, is equal to 1, then assign E, otherwise assign missing. So you can see that E was assigned, and let's copy. You can see if it was 0, then it was missing. Similarly, when you do all the covariates, it's going to take a little bit of time, but you can do it in Excel using this formula the way I did it. And I'm going to show you the finished product, which is citalopram data prep that I did earlier. you can see that my assigned variables, race underscore depression underscore anxiety underscore and outcome, right? So now I did concatenate all the variables, so I'm going to show you what I did. Let's strata 2. So I'm going to just, you need to click. So here I'm going to click gender, race, depression, anxiety, phobia, OCD, alcohol, drug, hypochondriasis, somatoform, the underscore variables that I created, bulimia. Okay. So you can see that my strata was created if WE, concatenating all the variables, and if you copy it to all the cells, then you get this strata. That's basically what I did in SAS, and I just wanted to show you in Excel that it was not a very complicated thing. It was very simple thing that I just did in SAS. So now let's go back to our program. In SAS, I created some formats which will print if the case was 1, then it will, if the treatment was, value of the treatment was 1, then it will print case. If it was 0, then it will print control. Similarly, if the outcome variable was 1, then it will print success, and if it was 0, then it will print failure. Let's run it. It will not do anything at this point. It's just defining the formats. Now I did a proc report which will give you a nice report of your data set just to see the data. And what it does is I close the listing, so you will not see anything in this window. Rather, it will create a RTF file. Then you can see what is in our data just before we do any balancing. So this is our unbalanced data. I'm going to run this, and I'm going to show you where this is citalopram table, and this is my rich text format. So this is what I just ran, and you can see that this table shows the strata, control and cases for failure, success, and failure and success, total number of case and total number of control. This is just a nice tabular form of seeing our data to see how many are cases, how many are controls, and among the cases how many were success and how many were failures. So and it's nice to have the table so that you can go back and see the number of cases and controls in your data set. Now the question is, why do we need to balance the covariate? The question we are trying to answer is the probability of a covariate. For example, probability of being female, is that same in cases and controls? We are not even dealing with the outcome at this point. So our question is the number of females in cases is equal to the number of females in controls. If we see in our data, it is not. So we are going to balance in a way so number of females will be same in cases and controls. If it is not same, then we will adjust the weight such that it is same. To do that, I have written a code that will calculate the odds ratio, the unbalanced odds ratio in unbalanced data for the covariates when I cross tabulate that with the treatment variable. And I just want to run this one and show you how that works. So this is called a macro, and when I run each of these, here I'm calling the macro. This is the part of the macro, the whole macro that I wrote, and here I'm calling the macro. So when I call the macro for gender and run it, you can see SAS gives you a nice 2x2 table where so table of presence of panic disorder, which is our treatment group, by gender, which is unbalanced data. The treatment is on the left hand side, which we also sometimes called exposure, and the outcome in this case, what we are trying to find out is gender, which is a covariate, is male or female. You can see on the bottom the odds ratio is 0.86 and 95% confidence interval. The way we want to express this odds ratio is, or interpret this odds ratio, is the odds of being a male among the cases is 0.86 times higher among the cases than in control. So odds of being a male is 0.86 times higher among cases than in controls. So let's go back to our code and run another one. You can see here the race underscore, that is white or non-white, and then again it is cross tabulated. This is a 2x2 table cross tabulated with treatment, or which is our exposure. The odds ratio is 0.55. If you run all of it all together, let's run it all together. You can see it runs one by one, and the frequency tables are created here. However, I do not want one by one. I want all of these odds ratios and confidence intervals in a nice table, and I created that in my coding. I called it unbalanced OR. This is my data set that has all the unbalanced odds ratio with upper and lower confidence interval for each of the covariate. This is covariate. So as we saw, I rounded it to 2 decimal places. Gender 0.87. You can see somatoform is pretty high. It is 8 times higher. Among the cases, hypochondriasis is also almost 8 times higher. OCD almost 5 times higher. Anxiety is almost 6 times higher. So our data is really not balanced at all. So we are trying to balance this such that this odds ratio will be 1. So how we do that? Now we are going to count. We are going to do a count of the strata by treatment group, whether cases or controls, and output the count in a count table. And we are going to exclude where the treatment is unknown. So if we don't know whether a particular patient was in cases group or the control group, then we are not going to include that observation because we simply don't know where we should put that. So we are going to run this, and here let's go to the count table that we just created. You can see in the count table this strata Fn has treatment 0 and treatment 1. So treatment 0 is control group. For control group the frequency count was 49, and for case it is 4. However, this data set is in a long form. We really cannot manipulate this data set unless I have these two up and up, which is in 2 rows. I want those 2 rows in a same row. So I'm going to manipulate that. I'm going to transform longitudinal data to white form, and in SAS we use proc transpose to do that. Let's do proc transpose, and it worked. So this is my transpose data set. You can see that I have achieved what I tried to do. So per strata, one line per strata, number of control and a number of cases. Now we are ready to calculate the weights, which is simply dividing the number of treatment divided by number of cases divided by number of controls. So let's go and create that data set. So here is my weight. You can see the I have divided number of cases by number of controls for each strata. Now you can also do this in SQL. So you can write a SQL code inside SAS where I can create a table count underscore case as select strata count of treatment as count treatment 1 from citalopram where treatment is equal to 1 and group by strata. And the same thing, I'm creating another table count control as select strata, and I'm counting the treatment where treatment is equal to 0, and I'm going to group it by strata. Lastly, I'm going to create a SQL underscore weight table where I am selecting the variables from these 2 tables that I already created, count case and count control, and I'm dividing the number of cases divided by number of controls as weight. So if you run these 3, first let's see count cases, count case table. So it just counts the number of cases. Next we will see count controls, which counts the number of controls per strata, and then we go to SQL weight, which joins these 2 tables, count cases and count controls, and calculates the weight by dividing the number of cases divided by number of controls per strata. So there you have more than many ways actually to do it. I just showed you 2 ways to do it. Now this is the end of alternate SQL code that you can use to create the weights table. I'm going to run this code, and you can run this code to create the this actually prints out the weights table that we have in a Word document. It's RTF, but you can save it as a Word document. Now, what we want to do with the weight table is, so let's open our weight table. We can see for each strata we have a weight, right? So I'm going to merge this weight table to my original table, which is the citalopram, which also has strata. So this variable that I have and this variable that I have, I'm going to merge these two variables, so each row of my original data set will have a weight. So each patient will get a weight. Depending on cases or controls, we will apply the weight. And let's go. So before you merge in SAS, you must sort the data set, otherwise you cannot merge if you are using a data step. If you are using SQL, you can merge without sorting. So I'm going to sort my original data set by strata and also the weight data set by strata. Now I'm ready to merge using the merge statement by strata, and I'm going to keep if observation is present both in the weight dataset and citalopram dataset. In other words, if for some strata there were no such weight, no weights, we did not calculate anyway because either cases or controls were missing, so there were not any case or controls, we did not find a match, then we are not going to include that observation in our final data set. So this is citalopram weight, and we are going to run this. So what I have done is assign a weight of 1 for cases. For controls, we assign the weight of the weight variable we just calculated in weight dataset, and we delete any observation if weight was missing. So let's go and see how our citalopram underscore weight dataset looks like. This is our original dataset. We are familiar with this one. If we scroll to the right, this is our strata, and each strata has a weight. You can see each strata has a weight, but you can see weighted observation. This was our original weight, but weighted observation will be 1 if the person was case. So treatment is equal to 1. So if treatment was 1, then weighted observation will be 1. If it was 0, then that means the person was a control, and we are going to apply the weight of the weight variable that we just created to the weighted observation. So in our data set, you can see each and every observation in our data set has a weight. Now that we have calculated the weight, now we are going to calculate the weighted odds ratio. So our weights we will weigh the odds ratio using the weight statement and calculate the balanced odds ratio for each of the covariates that we created before, that we just calculated the odds ratio for unbalanced data in our unbalanced odds ratio data set. Let's take a look at that. So this was our unbalanced odds ratio, and as you can remember, it varied from 0.55 to as high as 8. Now we are trying to balance the data. Okay. So if you scroll to the bottom, here. Now I'm going to run the same code and let's see what happens. So it gives me odds ratio. For example, this is a last one, treatment, and this is a table of treatment by bulimia nervosa, and then odds ratio becomes 1 because I weighted here in the weight statement. I weighted my weighted observation was the variable that used to weight the observations. Each and every observation was weighted using this weight variable, and that gave me weighted odds ratio. And I have a nice data set that has all the balanced odds ratio, and we can see here that our balancing was successful because each and every covariate has a odds ratio of 1. Now we can do a nice graph. Remember the two tables that we created, balanced odds ratio and unbalanced odds ratio. These two tables, I'm going to join these two tables so that my balanced and unbalanced odds ratio are in the same table. So here to join, as you know, we have to sort the data sets, and you can also use the SQL code. I used a data step. Okay, now it is sorted. So if it is not sorted, then SAS will complain. Okay, now we have successfully merged the tables. Where is table? OR. You can see the balanced OR and unbalanced OR. Why I merged? Because I want to create a graph that will show the balanced and unbalanced odds ratio for each of the covariates. So I run this part of the code. It is SAS sgplot, but you can also use SAS gplot. You can also use Excel graphs. It is not important what kind of graph you use, but a graphical representation is nice to show the results of your covariate balancing. I'm going to run this code, and it creates a sgplot. Let's see what it creates. There you go. So it's our graphical representation of results of stratified covariate balancing. That's my title of the graph. And on the bottom you can see all the covariates, 11 covariates that we balanced. The odds ratio is on the y-axis, and on the bottom you can see unbalanced data is represented by the blue line, and it is all over the place. You can see it goes as high as up to 8 as we saw. It also goes below 1. So we also saw that for race it was 0.55. So it is very unbalanced. You can see after we balance the data, the odds ratio stayed at 1. So here is the proof that our stratified covariate balancing was successful. And I want to show you the graph PDF that I created. This is a PDF file that was created. It can be copy pasted anywhere. So that concludes my presentation for stratified covariate balancing. I hope that it was helpful to you. Thank you so much.